Okay, so I guess we can start now. Okay, so good morning again, everyone. So welcome to this part two of my webinar. And I just have to show my screen. I forgot, but anyway, hopefully you can see now my screen. Yep. Okay. So again, good morning, everyone. Welcome to this second part of my webinar for this um, month or ending of this year. So now is previously I have highlighted to you the new versions of Precast design and detailing for Allplan 2024. So to just do a recap, uh, so so again, yeah, my name is Jayson Panganiban. So I will be your presenter this morning again, and then I'm the technical specialist for Precast of GSI Group, with a lot of experience using Allplan Precast module. So this is what we have previously webinars, the former design planning beam. So, and also what's new with Allplan 2024 for engineers. So if you are interested for these two topics, then you can also find these videos on our website or on our social media accounts, the GSI group, or even the Allplan Asia Pacific page. So you can find by LinkedIn, YouTube, Facebook. Yeah, you can search for those social media accounts. So our previous topic was actually, so we did this new interface. I have shown you the new interface of Precast Elements. So Precast Elements is another type of Precast module. So as you know, I mentioned before, we have three types. We have the eye wall, we have the eye slab, and also we have the precast element. So what we did before, or the part one, is was the precast elements, showing you how it is now with this with the object palette and how it looks like. And then we also discuss about the fixtures interface. So from previously, we are only getting the fixtures from the catalog, but now we can also see this on the library, on the palette library, on the library palette. So yeah, we can put all the fixtures either of these two locations. So it's easier for you to take these fixtures. Improvements of the in the element plan. So as I highlighted to you, these are the most very requested improvement from most of the clients, with the extension lines for their dimensions, so that it's easier to really locate which are the parts that we are dimensioning because of these extension lines. And of course, another great feature is the favorites for the layout catalog, wherein, as per experience, I have to create them one by one without the functionalities of saving it previously on the lower versions. But for now, for the 2024, all the items on the layout catalog has the functionality to be saved with the use of as your favorites. So whenever you're going to use them, you just have to load them, find those files, and then load it. And then it will have the same settings or same properties as the other layouts or settings. I have shown you also the general improvements, like for example, the IFC export with a color. So as mentioned previously, it's not possible. It only exports one color, but now you can define, let's say for column, you will export as red color. For beams, you will be exporting as green color, and then for the rest will be other colors. So it's possible now for the beam users to really distinguish what are the colors or what are the elements they are exporting. Of course, including here are the attributes that you can already identify from Allplan design. Then also have the joint reinforcement. This joint reinforcement is, we call it the Python part, wherein we can easily do the connection between joints. So this is really a great development for the detailers, for those who are detailing the elements, which you can still modify once it's placed. It still can be modified anytime. And then, of course, when I say modification, when with the rebar, it can be modified on the 3D itself. So basically, previously we are not able to do this. We just have to create views, we have to create sections in order to modify the reinforcements. But from this Allplan 2024, we can already have the modification of the reinforcements. So we can change the length, or informations like diameters, how many bars. So we can already do that even in the 3D or isometric view. Okay, so this was the part one of the webinar, what we did last 26th of December. So now we will be moving on to the part two, wherein we will be doing the deep dive of this precast, not the precast elements, but we will be discussing now with the eye wall. So this is, as I mentioned, this is another module, precast module, wherein it will make your detailing or design faster using these eye walls. So we will be talking about a simple workflow. Of course, there will be different workflows depending on your requirement. But for this part, we will be discussing a simple workflow of how we can use the eye wall. And then, of course, from the modification part, we can discuss some using of planes. So meaning, because we will be using the architectural wall, so our wall will be depending on the planes. So we can do some samples of using the planes to really define the height of your elements or your wall. So this is, let's say, for example, you want to have an upstand wall, on our upstand part of the wall, then we can use planes, or we can also add really the upstand wall functionality of the architectural elements. And then we can have, from this eye wall, we can have the automatic division of walls, or we can also do manual divisions depending on your requirement. But I will be showing you both so that you can see how it is really modifiable, and there's a versatility of the functions of this. So it will be catering all your requirements. I can say all your requirements, especially for the walls. So these are just a few items, but when we go to the demo, the actual demo, maybe I will be showing you some more features for these eye walls. So as I said, this I will be giving you the workflow that will make your work faster because of these automatic functions, like creating reinforcements, or let's say for if you're working with double walls, you can have the lattice girders automatically placed. So depending on their setting, and then also on your requirements. So yeah. But I think for this case, we can move now to for the demo. So let me just open my Allplan. So okay, so now I already have the Allplan application. So from here, I already created a wall. So if you want, I can recreate it. So I can open, let's say, elements, and then here you can find all the elements that you can model, like wall, freeform wall, profile wall, and then the others. So for this case, we will just use the wall, and we have this property of wall. So yeah, we can define what will be the height depending on what. Okay, so let's say I will be depending on planes that I set. So this one I can just say 0, and then say, yeah, everything can be created like this, modify if you want some texture surface, you can still provide it here. I can just say, yeah. Okay, then I can open all those properties for the wall. So you can set these things up, and then I can just model the wall. So imagine we have a layout. So we can do the continuous modeling of your wall like this. So I don't know. I'm just trying to do some models here. So this is your, let's say, perimeter wall or whatever you want. Okay, so this is how I did on this also. So they are really the same process. So that's one way of modeling. So this again, our topic is the basic workflow. So we will be creating models, we'll be creating them as precast elements, provide the fixtures, and then create the shop drawing or even for the production data or creating the production data for your production. Okay, so I can now delete the lower one. Okay, so I have this model now. Of course, there's no opening yet, but later we can provide it. So either you model it already now, or you can model it later. So it depends on when you want it to be modeled. So I will just show you how it works. Let's say we provide the door opening. So even if you can see, even if it's an inclined or a sloping on the layout, it can still detect the area. So I will just provide some openings. Okay, door swing, it doesn't matter. So I just cancel. Let's say I have opening here. So just click. We'll just have to define. So from, let's say here, I have this reference. So I can say not 1000, but only 500 or let's say 200 from the edge. So it can define this part as the 200, and then you can have the opening, let's say 110, let's leave it. Oops, sorry, I escaped it. So I can double click on here, again, provide the 200 offset from the corner, and then just say enter to make it actualize, and then I can continue. So from this side, I can change the orientation to be here, so I can define from another 200 offset from the corner and then say enter. So imagine this is just a simple project that you have. So we already finished modeling the perimeter with the opening for the doors. Or that if you want also for the window, then you can define for the window. Again, the parameters can be set from here. So I can just say enter, then define so that we entered the reference and then define the width. We can change this, let's say about 1.5 exaggeration of the width of the window. So I already have there another one. So I can define from this reference point what will be the offset of another window, let's say about 1.5. So it will move from that part, and then I'll make this longer. Let's say. So I have this opening now. So yeah, this is just a rough modeling part of the walls. So now we have these walls modeled. They are not yet precast walls. So what we're going to do now is we will go to our precast wall. So and then from here you can see the design wall. Okay. So from this design wall, we have these functionalities of design mode. We have also the connections, we have the divisions, and we have the basic reinforcements. So from this part, we will just need to first to design the mode, or yeah, we use the design mode. So we design the design mode, and here you will have these properties wherein you need to set depending on your requirement. So for this case, we have different type of wall. So we have the concrete wall, which is the solid wall. We have the brick wall. We have the double wall, sandwich, thermal, and composite sheeting. So what we're going to do now, let's say for the double wall, for those who are using double walls, let's say especially for those different season. So remember they use double wall, and then you can see from here you have the visible leaf, you have the in situ concrete, and then invisible leaf. So with these things, we can define it here by clicking the three dots there, and then you can see also these three types. So for this case, I can change the thickness from 60 to, let's say, 80, and then this one also will be 80. So you can define like this, and then you can define all of them. Let's say the concrete grade, you just have to select one and then press the shift, select the other one. So you can select these three, and then you can select them all together for the material. So all of them will be the same. Okay, so let's say okay. So now we have this thickness. So I can just select the external part of the wall. So what I did here, I just right click to see the summation icon, and then select the external walls to be my double wall. Okay, and then I will just right click again to actualize it. So as you can see, they have markings now. You see them. So I can change their mark numbers from this level, these attributes. So I can change them to, let's say, 1. So as you can see, that automatically change their numbers. So again, you can define some of the properties here. We have some additional attributes you can define also. And then of course we have these layer adjustments. So since it's a double wall, I think it's better we change it to more thinner size. So I can still change since I'm still active on this wall. So I can change this to 60 again. So let's zoom in so you can see this part. So yeah, I think it already changed. I can do that again for the other one, make it this 160. So you can see it changed and the information also changed. So you don't have to worry of changing every time if you don't have to worry on, you might forget to change something when you change the other elements or the other properties. Okay, so this is what you can have now, right? Okay, so this rotate from height and minimum rotated length will be depending, of course, on your production capacity or requirement, and also for your delivery. So basically I can just leave it like that, or if it's really possible for you to give the maximum value, let's say 5 meters or 8 meters, then you can just adjust it. It will automatically define for you the division for later. Okay, so next what we're going to do is that, excuse me, we will be creating now, let's say for these internal walls. So I still have this functionality when I can just say escape first to really deactivate the settings, and then I can change this to a concrete wall. Okay, so same concrete grade material, same settings. Then I can just activate the internal walls all together, and you can see I have my precast elements created. Okay, so I can do escape, and then as you can see, they already have this marking, means they already converted into precast elements. So it actualized also, of course, with these openings. Now what we can do next is that we can do some um, divisions. So let's say, for example, I just click on this, okay, and then from here I can say the maximum length or no division, it depends on you. But let's say I have the maximum length or equal element length, okay, and then let's say I select this wall, internal wall. So as you can see, I have the same length, 3.51 meters, 3.51 meters, because we actualize it as equal element length, okay. But let's say maximum element length, let's see if it will change. So maximum is because Our maximum here defined was 6.52. So we still have this zero point 0.5 meters here. So it can be divided into this setting, or we can just say, just use the equal element. So of course, equal element can be easier, especially for your production and for your delivery and also for your modes. So you will be using the same size of modes. Okay, so that's one part. And then for this case, we can say for the joint, we can provide. So if it's, let's say the normal is 20 millimeter, so it will change to 20 millimeter. If you want to have something like a symbol fixtures, okay, we can define symbol fixtures. So for this case, you can see that I have three dots here, wherein I can define two different fixtures or two different sides, so left and right. So what we can do is the other one will be midpoint 2, this one will be midpoint 1, and then I can select both and say I will go to my project. I can go to my flexible loop and say select, let's say fixture this part. Okay, and then what will be the possible offset of the fixtures? Let's say about 1000, or you can say 750. So they will move wall height to 0 and then move thickness wall 0. So I can just leave it like that and say okay. So as you can see, I have this um, fixtures embedded. So you don't have to worry about, I forgot to put my fixtures on this connection. I have to create views again to create, but here we can already provide it. We can also have this connection setting. So I think we can use the v default. So from this v default, let's say, so we do the same thing, activate the fixture. Okay, then add one more, direction 1, I think this direction 2, so that will be left and right. So we do the same thing as before. Go to my project, go to flexible loop, and then Fiber slim box 80 size. The offsets will be 750. I make it more, so let's say 500. And say okay, and then you can see it exceeds on this part. So we can say define, let's say about 1 meter. Oops, that's only on the other side. Then I forgot to change this also 1 meter. Okay, so we'll have it exactly as this. And because we forgot to do some settings here, so it will be, instead of distribution from bottom level, so we can distribute this from the middle. Okay, so let's try again. Let's say make it 500, so you will not have an exceed there. So you can see I already have my more loop box fixture. So yeah, so it's not only for this wall type, not only for the concrete type, but also of course we can do that in the double wall. So I will just have to escape as mentioned here, because I just created the 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 connection here. So I will just escape and then select another wall. Then I will have this division for double walls. You see, since we make it an equal element, then default one. We don't need default one because we don't need so much connection because they are already the skins. So we will be providing the connection between filling in the middle part of the double wall. So they will be connected directly. And from here, it says that I have the minimum length for the 500 and the maximum length of 7,000. So let's say if we can see that we have exceeded 7,000, or we can change this. Let's say, for example, only 5,000 is the maximum, because that's allowable delivery for delivery. So we can just change this and it will automatically divide your wall according to this maximum length. So since we put this at equal, so all of those will be equally divided. If we say maximum, then it will give you the maximum 5,000, I think. Yep. So it will be giving you the maximum 5,000, and then the rest will be this part. Okay. So this is the purpose of the minimum and maximum. Okay. So dividing height. So this one I can discuss later, and I will show you that on the other wall type. So this is basically the properties for the division. I can escape, and then I escape so much. So I'll just go back there, division. I can do also manual connection. So if I say have a corner here, I have the corner, the end, and the wall and the mandatory joint. So mandatory joints means you cannot you can select where you want to place your connections between the elements or want to divide. So for this case, we use the connection corner, and then let's say select these corners, and you can see you will have these connections on the corner. From this case, you will have different options, like let's say zoom in, and then for the default two, you can have on the other side for the external part or the visible part. This one will be for the other one, the invisible part. So you have this part, and then you also have the miter 45. You also have this part mitered on the other side, or you can just have the free connection. So everything was cut. Okay, so for this case, I can just say this part. So this part will be cut. Okay, so we can do this on the every corner. So yeah, escape, select corners. Yeah, and this for this part, of course, this is not a corner, but it can still provide you the connection. So it will just cut off this part, or you can say you can change this to any kind of connection. So as you can see, it gives you more connections. So it will give you this kind of connection depending if you need some fixtures. So let's provide some fixtures here, and we do the same. So let's say I have this direction 1, direction 2 will be direction 1. Oops. Yeah, this connection. Oh yeah, because we don't have a cutout on this. So what we can provide is, let's try. So I office to make this project, select flexible loop if it's still usable. Let's see, and then 80, same 500. To the from middle, so select, and I will have this flexible loop on this side. So for this direction too, we don't have other option because we don't have the connection properly on that. We can change this to other connections. So you can have this also. You can define a miter, yeah, on this side, or division axis. So you can have this kind of connection. So you have different types of connection that you can use for this situation. Okay, so moving forward, so this is for the division, and then we can now, let's say, create the basic reinforcement for this lattice gear. I mean for this double wall. So basically, we can provide the lattice girder, which is really usable. So let's say girder type will be, let's use this. So this will be based on your setting on the lattice girder catalog. So later I will be showing to you where you can find this. So I can select this part, and then it should provide something. I forgot to see the error. So Okay, so they have, yeah, I forgot to set some settings here, but there should be some lattice girders to be shown. Usually I have this lattice girder, so it, so as you can see, it does not provide something, it becomes a B because there's some error, which is, I don't know why, it gives me this error, wall 1, wall 11, invalid steel grade. Okay, so I think I did not set more on this. So it's a matter of setting the correct, let's see, factory type double wall, yes, reinforce. Okay, this is, so we forgot to select the settings. So this is a mesh. This is the bar reinforcement. So let's say we can use this. Yeah, we can use again this one. So it's now yellow. So I think it created something already. Yeah, something like this. So as I mentioned, we have to do some settings here to be able to identify or to create the reinforcement. So this one also have to be defined. So we can select, then this should be required reinforcement type. So which is the available that we have. Visible and invisible. Let's try to select something here. Then reinforcement type touched. Oop, there should be something. Span direction automatic. So you can have this visible. What happened? So I already attached my reinforcement parameters. Yeah, it should be fine. So if I make it loose, I thought I selected my parameters. Anyway, so we can see that there's already some lattice girders here, but it's not properly placed because of the settings that we provided. So let's try to modify this offsets. Oh, we need to have some, let's say 100. Axis offsets, we provide some information here, not only 0, but let's say do some parameters here. Just start 100. Let's put some, deactivate this one. So as you can see, we have this lattice girders already created. Can we make it bigger? Because it's quite small. So, oh, it's too big. So we can use, let's say, this one. Yeah, I think it's too big. Smaller. Yeah. So we can have this lattice girder. Okay, offset openings, let's say 100. So we can have these offsets to the openings. Then edge offset, let's say 500. Yeah, so we can define the edges. So from here, you can already define what will be the setting of your lattice girders. There should be some other offsets. If I make this deeper, so let's make this 1000. There you go. So we can modify axis offsets, of course, what axis, so we can have this already placed in here. So I just say escape. And then as you can see from here, I will just make it objects, the precast elements to be hidden. Oop, not this one, but the walls to be hidden so that you can see the reinforcement. Reinforcement should be not be affected. Walls, yeah. So, okay, if that's not work, then we can just say from here, set surface to be 50. Already. So as you can see, there's already there lattice girders connections. So basically, we just have to do some presets on this, and you don't have to worry because once you already have this set on these elements, then you can have this saved as favorite, wherein every time you're going to use the same property of this, then you can just have to load it and get it from where you saved it. So it's not that difficult. That okay, at the beginning you will have to set it first, and then once you already have the setting correctly, and you will use it the next elements, then you can just load it in. So you don't have to worry of I have to set it again one by one. So you can have these favorites and also load the favorite. Okay, so that's how you're going to put some reinforcement, and of course we can directly create the precast elements from there. So from our workflow, we have created the model. We created them as precast elements. We provided the lattice girders or reinforcements, and then now we can generate the shop drawing. So actually, generation of shop drawings anytime. Once it becomes a precast element, you can generate directly the element plan, or you can generate the element plan later. But for this case, we can generate now by clicking this icon and then selecting which element. So let's say I'll be selecting this element, and then you will have to select what type of layout you're going to use. So let's try to use this, and I will have now my element plan ready. So what can you see from this element is basically you already have your model or your element, and then you can also have your lattice girder information. So for this case, we can use the legend and then say the import engineering precast elements. We have the lattice girders here, girder legend. So I can use this and then I can place it here. So I will have my girder information. So what are the girder that I have used on this element? Okay, so this provides you the information of your concrete weight. You have also the rebar weight, ratio, quantity. If you needed those information, you can have those in one click of the element plan. So this is really, I can say, the fastest way of having your element ready for your production. So aside from this, now I'm showing you the element plan. I can close this part. Then from here, I can also provide you the fixture. So I can just go to my fixture and say either I go to my library or the catalogs. I can go to my catalog and let's say I want to have my project, let's say this webinar, and then use the propping. So I will just have the propping. And as you can see, I will just have to deactivate here. So I can select from here, from my plan, select here, and then specify the height. Let's say 1 meter. So as you can see here, I have the fixture. Say OK, then it automatically gives me dimension for my propping insert. So you can see there. And then of course, it also shows here. So wherever I work, even in the even in the element plan or in the model, if let's say I do a copy of this fixture, let's say from which reference, z-axis, let's say another 1000. So I can still work with that, and it gives you also the dimension automatically. So you will not you don't have to worry that you might need to dimension it or change it again your element plan, because it actualize whatever you have modeled on your um, modeling um, view, not only on the shop drawing. So again, either I move some, let's say I make this in plan view, I move the window, then I can just move here. So it will automatically adjust also that information. So this is the basic workflow of the wall. Another good thing here is that I think I did so much explanation on the wall, but this is really a very important way to discuss you the whole workflow. So we're already exceeding our time, but anyway, I will just continue. So another thing here is that you can use the we can go this sample. So I have a big wall here, okay, a big wall, and then when we go to the division, so we just go division and say uh, define this as precast element first. So you have this, and then we go to divisions, but I can just use this as double wall, and then from here I can say that I can have the height division. So this is 10-meter high wall. Then I can just have to select this one, and I can automatically have my division equally. So for this case, I can say it's instead of division of equal maximum equal length. Yeah, so maximum, let's say about 3 meters. So it will automatically divide in 3 meters. And let's say, for example, this part will be totally different. So what I can do here is that, let's say right click. Let's say the division is not like this, but this part will be different. So I can say I will remove the section. So they're totally separated wall, different wall. Then from this part, I can do division. Say select this part, and then let's say not same height, but different heights. So as you can see, it's now different, right? And then of course, aside from that, you can do customization of your division. So let's say I don't want some divisions here. I can just select this division. So this one will be the no division also. Yep, there is only one element. And then I will just use this modify wall in view and select this wall. So from here, I can do customization of my division. So for example, modify wall in geometry. So I will select split wall element. So I just provide this information. Let's say from here, I'll just pick somewhere here, and then I will just divide my wall, and then say escape, and then I will have my wall here divided. And then also from vertical, I can create from here to here, escape. So I will not have now have my two walls. And of course, this is customized, so you can also have the slope division, incline division. So let's say from here to here to here, make it equal. Then I can say escape, and then I will have my wall now. Okay, so as you can see from here, I already have divided my walls according to my needs. Okay, so this is a very important and useful way of using the precast elements as the eye wall, and you can divide anything you wanted to divide. And one more thing, this is also important, that even though you are using a 3D element here, let's say I created 3D element, So the height will be something like this. This can also be converted as your precast wall. So this is very a new development for the eye wall, wherein I can select this wall, and then it will give me division as this. I can convert this as a precast element, because in the lower version, it's not possible to use the precast wall on the 3D model. But for this case, I can already have I can use already the 3D model. So if you can import some models from other softwares, let's say the 3D model, then it can be converted as wall, and then you can do the same procedure as what we have done. So just go back on the model from here, because I mentioned that I'm going to discuss that you can generate the PXML file or the data. But first, I can do a report of this. So I can say I have the report, and then let's go to my documents, report. Let's say I use this one, and I can select all. So I can generate a report of all my precast elements in one click, just selecting it, and then I will have my information. So again, this report is really useful. I can select this element, and it will highlight which element I am selecting. So yeah, it can define your which wall you're looking. So that is this report. And then of course the generation of data. So I can generate the data using this production data, and then just select the element. Okay, and then I can have either PXML or Unitechnic file. So I will just try to use the PXML file and then just start NCGen. So of course I have some errors which are not really preset, but if I go to this information, I already have generated this data, wherein you can pass this data to your production to the casting of the element. So this is a great workflow for the for your for any project that you're going to do. So this will be coming from the engineering side up to the design, up to the detailing, and then to the production, and of course for your delivery in the future. So it's really a really I can say a fastest way of creating or designing your precast elements. So I think I have exceeded so much time on this. So if you have some questions related to these topics, you can just send me an email. So maybe I can share again my screen. So let me share my screen again, and then show my presentation. I did not notice the timing, but anyway, so I can. So from our social media platform, so we have this JSI Group LLC website. You can see our website. You can search for our website. Also, we have a YouTube and also in the LinkedIn. And then, so upcoming webinars, I will be showing you, or I'll be giving informations, excuse me, for the next webinars. So if you have some questions, you can directly message me from this numbers. And then also you can scan this QR code for your easy saving of my numbers and also my information. You can also send me email from this from my email, jpanganiban@gsisoftware.com, and then I will be happy to answer your questions um, if you have questions from me. So yeah, I think I've exceeded so much time, so I don't want to waste also your time. Thank you so much for listening, and hopefully you have um, gained more knowledge about how Allplan precast can help you on your daily job for your precast elements. So uh, yep, I guess I have to end now. Thank you so much for listening. Bye bye.